Okay, hello everyone, and welcome to our discussion panel on careers in machine learning. My name is Bazińska. I will be moderating the discussion, and today with me there are our guests, Viorica Patraucean from DeepMind, Karol Kurach from Cosmose, Ewa Szczurek from University of Warsaw, and Łukasz Bolikowski from PCG Gamma. Our topic is careers in machine learning, and in the beginning I would like to ask every panelist to briefly introduce themselves, just so we could get a bit of an insight on their background. Can we start with Viorica? Could you introduce yourself?
Okay. Hello, everyone. Happy to be here, and thank you to the organizers for inviting me. So I'm a research scientist in DeepMind currently. I'm originally from Romania. I did my PhD in France, working mainly on image processing and video processing. And then I did a postdoc in Cambridge, the University of Cambridge, and then I moved to DeepMind. So currently I work on computer vision problems, but using RL, supervised learning, generative models, like all different tools to help make progress in vision. So this is kind of my passion to understand the vision and to understand it also from the neuroscience perspective, to understand how our brain does visual processing.
Thank you. Thank you. Could you also answer one tiny question? What made you choose the path that you chose?
So I think I had a part-time job during my undergrad when I was doing programming, and it was very exciting at the beginning. I was learning a new framework and so on. And then the second project came, and it was a bit kind of the same. And then the third project, and kind of repeating. And I kind of said, okay, maybe this is not the thing that I want to do on a longer term. So that kind of pointed me towards research. That I want to research, that I want to learn all the time, and discover stuff. And that's how I got into the research and decided to do a PhD. And during PhD, I started learning about the brain and how the brain does the processing. And I really found that fascinating. And it's still with me, like the passion to understand better how our brain works.
Okay, thank you. Maybe now we can move on to Karol.
All right. So, hi everyone, I'm Karol Kurach. Thanks a lot for inviting me. So, in a nutshell, I did my master's and PhD in machine learning at University of Warsaw. I worked for 8 years at Google in Zurich. For the first 4 years, it was more on a product team called Gmail Intelligence, working on features such as Smart Label or Smart Reply that you might have seen in your Gmail inbox. Later, I moved to the pure research team, which is Google Brain, and I worked mostly on generative models and RL. And this year, I made like a bigger shift, and I left Google, and I joined Polish startup Cosmose as CTO. And yeah, I'm currently here.
Okay, good. And a tiny question: why did you follow the path that you chose?
Okay, maybe how I got interested in machine learning. So I think for me it was that, like, for most of my high school and studies, I was like really into competitive programming, and then I figured out that okay, those problems are cool, but they already have a solution, so they are not that interesting. And I was looking for something like more interesting. At the same time, the Kaggle platform was starting, and they had those, they were like really first machine learning competitions. And I felt like, yeah, I was doing good in programming competitions. Maybe I can do well in the ML competitions. And that's how I like got interested in the field. And then obviously I realized, okay, that maybe those competitions are not as representative of real world problems, but still that was something that really got me into this field.
Okay, great. Eva, would you like to introduce yourself?
Yes, hello everyone. I also really want to thank the organizers for, first of all, arranging such a interesting event overall, and also for getting me here on this panel. So to introduce myself, I'm now an assistant professor at the University of Warsaw. I work in machine learning applied to mostly computational oncology, in the broadest sense, computational biology, molecular biology. I did my PhD at the Max Planck Institute for Molecular Genetics in Berlin. Later, I did a postdoc at the ETH Zurich. And since 2015, I'm leading a lab, a research group in Warsaw.
Okay, good. And the classical question.
What made me choose the path? Yes. Well, okay. I was actually, since studies, I was really decided I will do machine learning. Somehow I really liked. Then it was called something else, like data mining or whatever. There are always these names that are fancy. But I really liked algorithms that solve real life problems, and I really liked statistics and data analysis. I really liked playing with real data. And also I felt always super motivated by solving important problems. And I found really important problems for me lay in healthcare, in understanding complex diseases, and applying. Now I feel like I'm really super motivated and doing something really great because I'm working on cancer and applying AI to cancer. And I feel this is essentially, methodologically, this is what I really wanted to do, but also in terms of applications, I feel this is something very important, and that's what really drives me, at least. Okay,
that's good. It. Thank you very much. And last but not the least, Łukasz.
Yes. So starting with my education, so I graduated. So I did my master's at University of Warsaw at MIM, and then my PhD at Polish Academy of Sciences. It's computer science in both cases. And I worked for 15 years at Interdisciplinary Center for Mathematical and Computational Modeling. And then after those 15 years, I moved to corporate sector, to private sector, and I'm currently an associate director data science at Boston Consulting Group, and here I'm primarily I'm working with companies worldwide and applying mathematical modeling to help solve their business problems. And essentially that's kind of and that very often that basically consists of either applying some machine learning techniques or operations research techniques to operationalize some solutions. And what chose how did I choose this path? Yes, So I was always interested in math, right? It was from since I was a kid, right? So that and I also like applying math to real world, right? And this is basically the data science consulting is essentially that, right? You take a business problem, you convert it to a machine mathematical problem or data mining problem, and then you solve it, and then you have an impact on the business, right? So for me this is I mean it's true for what I do at BCG. It was true what I was doing back at ICM, where we also had we were working with researchers from all the different walks of science, from biology, chemistry, physics, biophysics, biochemistry, and so on, astronomy, and etc. And there's always okay, so there is this research question, and we have So let's have usually a set of partial differential equations that describe it. Let's solve it numerically and let's draw some conclusions, right? So the kind of the template is kind of similar, right? We have some real world problem. Let's translate it to a mathematical language. Let's solve it and let's apply it back to reality.
Mm-hmm. Yeah. Okay. Great. So I think now our audience knows who they're dealing with, and we can go on to the meaty part of the discussion. So let's first talk about skills needed in machine learning based careers. So recently we've seen a huge increase of demand for specialists in deep learning, machine learning, data science, whatever fancy names you give to it. And just to back it up with some data, on one of the most popular job posting platforms, between 2018 and 2019, AI job postings rose 30%, and machine learning and deep learning engineers were the most popular jobs posted. So there's a lot of demand, but there's also a lot of interest from the community. So how does a candidate actually become competitive? What skills are vital for a good candidate? So maybe let's start with Viorica. If you were looking for someone to cooperate with, what would you find important?
So generally, I interview candidates for internships, for example. And what really matters for me is to see that the person is passionate about the field, and that they're able to explain things clearly, that they have good understanding of the topics that they're discussing, because very often like the field has grown so fast, and it's like hard to keep up. But I think learning the fundamentals and understanding the fundamentals is crucial. And this is really what matters, like to see that the person really knows what they're talking about, and not just brushing at the surface and not getting the insights. And then, of course, as a skill, programming, I kind of take that is implicit, that you have to be good at programming. Other skills, let's say, I think it's very important for people to, at least in research, to be able to read papers, like lots of papers, and understand them very quickly, like in a skim, to be able to synthesize very quickly the information. But yeah, generally, I want to see people that are passionate and that understand the topic.
Mm. Okay, so would you say that willingness to learn is as important as the actual experience that the person has?
The desire to learn. Yeah. So yeah, exactly. That's another thing. So we want people to be able to adapt to a new topic quickly, because obviously the field is so big that you cannot be expert in all topics, but you have to be able to quickly jump onto a new idea. So being curious about things and wanting to learn. Yeah.
Mm-hmm. And one more question on this: would you say that some people criticize academia for just optimizing for the number of citations, papers published? Would you say that's something that's you just reject candidates who don't have anything published, or how would that work? Do you find it important?
Right. Unfortunately, this is not the decision that I get to make, because like for candidates to get to me for interviews, they would have to pass other filters already. So there are filters that, and I cannot speak how important it is, like for the very first selection, that I don't make myself. But yeah, I would not say that if you don't have a publication in a great conference, then you don't have a chance for an internship. No, I think as I said, because it happens, like there are so many directions that we can investigate, that some will just not go to a paper, But I think it's really important that people just learn and try ideas. Yeah. So no, I would not say that having or not having a publication is the factor that decides.
Okay. And maybe I could also ask Łukasz here about this, because Łukasz, you could maybe provide us with kind of an outlook which is comes from a bit of a different background in consulting.
Mm-hmm. Yeah, of course, some of these elements are the same, right? So of course, technical expertise, right? You have to know how to code. You have to know machine learning, deep learning. You have to know mathematics, statistics, and so on, right? That is kind of a given, and I believe it's common kind of everywhere. I also echo very much kind of the passion and curiosity, right? I think this is critical to have, like an outstanding kind of employees are the ones who are really passionate about what they do. They don't just do this for money or for like it really has to be kind of come from your heart in a way, right? Some things which might be a bit more specific to data science consulting and perhaps a little bit less pronounced elsewhere, but still probably present is like this problem solving skills, like business, so like business problem solving skills, right? So understanding the business, kind of like what's actually going on, and like so what do we what are we trying to optimize, and then how do we translate this again to kind of to mathematical kind of framework. So that's one thing, right? There is a lot about practicality and effectiveness, right? So to understanding kind of, okay, I can do this 50 different things now, but which one will move the needle the most, right? Which one will matter at the end, right? So that I don't kind of do things which will not make a much difference. I'll just be kind of idle, like empty effort. So understanding how to prioritize and how to be practical and how to get to solutions quickly is another thing which we take which we look at a lot. And finally, I would say communication, kind of especially I would say visual communication skills, but generally kind of ability to communicate your results back to non-technical audiences, right? Because most of our clients are not tech geeks, right? They are not math geeks, right? They know their business domain very well, and they want kind of straight answers in their language, right? So this is an art in a way, right? And this is a skill to be able to convert kind of like this sometimes very, very complex problem, very, very complex algorithms, right? Down to a kind of to relatively simple language without kind of losing the information, right? But kind of so conveying the key points, but in a way that is understandable to a wider audience, right? So I would say that these are so to sum up, the business problem solving, practically effectiveness, and communication are maybe something which is kind of a little bit more pronounced in consulting, right? But whereas I believe technical expertise and passion and curiosity are probably common to all of us.
Okay. Good. I'm happy that we touched also the soft skills aspect. Now maybe next question to Eva. So we all go through university education. We all go through some kind of a system. But do you think that this actually prepares us well for our future job? So you working in academia, still staying in more or less the same environment as the university. Do you really feel that university education prepared you well for your current job?
Well, I didn't really. I mean, I had one job in consulting, but I didn't really have any other preparation for my job. And it's for my job, you need also experience, like going to conferences, writing papers, applying for grants. There's a lot of expertise that I need for doing my job, which I just gained in experience. And I don't think that this should be actually part of the curriculum at the universities. But I don't know. So for doing research, definitely education at the university is very important. And I think also for machine learning research, there are these fundamental courses that you need to take, like linear algebra, probability, calculus, statistics, programming. Definitely, these things you can learn at the university, and I really. If there are students in the audience, I really encourage them to learn hard on these courses and to use the occasion to actually learn the fundamentals, but also use the practical courses that are currently available on many universities on like courses like statistical data analysis, machine learning are part of the syllabus in many at many faculties. So it's possible to learn the basics, and I think then experience definitely gives a lot, right? When you actually do research and when you actually practice different projects. What we lack very much, but I have no idea how to prepare people for this, is ability of synthesizing ideas, generalizing. I think this somehow is a quality that maybe needs time to develop. Really combining different ideas, combining different sources of information, and then being able to present it in a concise manner, and also to be able to write about it. So for research, definitely writing is a very important soft skill that is completely overlooked somehow. So we are actually producing papers in a way, and we need to be able to write them. And I think this is somehow a skill that is very often missing.
Mm-hmm. Okay, thanks for pointing this out. Karol, I see you also.
Yeah, I think there's like a whole range of things that is just like impossible or very hard to learn in the university, and like both in the soft set of skills and in the hard set of skills. So like, starting with the most obvious, like teamwork and collaboration. Basically the setup of the university is that, we are mostly working alone. You have your project, you get your grade. I mean, there are some classes that aim at doing the collaboration, but like, if you want to see one example how it doesn't work, then you can look at the STEAM programming project at University of Warsaw, which is like, even in, like, I was working with one team and they basically split in the end. So like the setup was the team project, but in the end it wasn't that team of an effort. So that was like example of a soft skill that is hard to learn in the university. But you have also lots of hard skills related to coding and like the maintenance, like, pushing the models to production. How do you do this properly? How do you maintain your models? How do you how do you make sure the code that you write can be supported in a long run, right? I mean, like usually for your class, you write a code, in 2 months you forget about this code. But like, what if you have to make changes in 6 months? Or what if you have to make changes, but you cannot change the interfaces that you designed a year ago, right? So those are those questions that I think are basically very hard simply because of the university setup.
Mm-hmm. Okay, and Viorica,
I wanted to add, if I may. So related to the soft skills, I don't know if this is specific to Eastern Europe. So I'm from Romania originally, so I did my first levels of education there. But I think we don't insist, like at least in Romania, we don't insist on the soft skills compared to Western countries, where I know like kids from very young ages, they are encouraged to get familiar with public speaking and more teamwork and so on. So I don't know if this is something that we could try to change in our education system in Eastern Europe. So I'm not sure if it's the case for Poland, but I think in Romania we should do better on that side. And another thing that I wish would have was different in my high school and undergrad was to have like mathematics, probabilities, disciplines to be explained in a more practical way or more down to earth. Like I feel they were, my background is in computer engineering, and we had like courses on maths and all that, but they were always just in a very abstract world. Like you couldn't really see how would I ever apply these in a real problem. So I really wish that this was done, like all these disciplines to be done more in connection with real applications. And this is something that we're actually now trying to do. Like in Romania, we try to set up a course AI for high school. And there we try to show to pupils, to students, how derivatives are useful, or that you actually get to use this in training a model and optimizing a function. So yeah, this is one thing that I wish was done differently, like to make better connections between the different disciplines. And actually something that I didn't mention earlier, like for skills, I think AI and machine learning, it's a lot about interdisciplinary research and knowledge. So AI is applied for medicine, is applied in very different areas. So I feel like ML scientists should also be open to learn details about a new field. You don't just say, oh, I'm an ML scientist, I don't want to learn about the medicine data or something. I think you always have to have an open mind and try to understand like details from different disciplines. So yeah, I think this interdisciplinary aspect is a very important one.
Mm-hmm. Okay, thank you very much. So now maybe to close the skills section, one question from the audience, from Mateusz Dorobek. What technical hard skills will be the most desirable for data science related positions in a few years' time? Here maybe Karol, maybe you would have some insights. Usually startups are the ones which follow the newest trends in technologies.
I don't think it's like about any specific technology. It's not like, learn PyTorch or TensorFlow because it will be obsolete. I think basically what Łukasz and Viorica and Eva said, it's like, for me, it's mostly three things. Like I always look at the three things that were already mentioned, like, the knowledge of the basics, the coding skills, like coding skills in general, writing bug-free code, because let's face it, this field is mostly experimental, and the faster you can, and the less bugs, the faster you code and the less bugs you make, the more progress you can make with your experiments. And the third thing is the curiosity and willingness to learn, because, unlike things like, if I'm a Java programmer, the Java obviously changes, but like, it's kind of the same Java that was like, 10 years ago, right? Like, it's not like they rewritten everything. While in data science, in machine learning, the TensorFlow didn't exist like 5 years ago, right? And, maybe like in another 5 years, it will be like completely different set of technologies. So if I'm thinking of hard skills, it's like programming in general, yeah.
And just keep learning.
Yeah, I think so. You need to be, that was also mentioned, right? You need to be curious about the field. If you're not passionate and, basically if you learn now and you don't want to keep up with like what's happening, then in 2-3 years it will be obsolete.
Mm-hmm. Yeah. Okay. Thank you very much for this insight. Now maybe we can progress on to the next category, and let's talk a bit about project management. So managing projects which are based on machine learning techniques can be much different than managing a simple, not a simple, but a software development project where you kind of know you will always progress. With machine learning methods, as Karol mentioned, it's more of rather an experimental science. So we never know what we'll end up getting in the end, right? So maybe Łukasz, you could tell us a bit in like what are some AI specific challenges in managing projects?
Sure. Yes, and there are some, I think, some elements which are specific or at least more, more often kind of seen in managing AI kind of projects. And one of these, I would say, is managing expectations, right? So our clients kind of for obvious reasons, right? And then it's completely understandable. Do not really kind of know what is the art of the possible, right, in the field, right? And it goes in both ways, right? It can be that they have no idea that something is possible, right? That actually we can solve this problem, right? Or or the other way around, that that they think, okay, so now this is a magic box which can do everything, but but actually what you're asking is kind of impossible, right? I very much like and probably I think many of you, if not most of you, probably read XKCD, and like a long time ago there was a nice comic about, I think it was about like image recognition and about like I don't remember the details, but basically there was a one part like, can you tell me if this photo was made in a park? And there's yes, that's a simple query. I just look at the metadata for latitude, longitude query, and that's I can do this next week, right? And then okay, and can you tell me if this is a picture of a bird, right? And it was actually a long time ago when this was not like now. It's a bit easier, but then it was like, yeah, I need a couple of months and I'll get you this feature, right? So it shows like things which can sound like two kind of like equal features for a kind of somebody who's from outside the field are actually very, very different in terms of kind of effort, right? For the practitioner, right? So again, managing expectations is I think one element. Then Karol already mentioned kind of model maintenance, right? And kind of the model's age, right? And I think it was probably never as acutely seen as in the basically as in 2020, where like before, like the kind of the typical situation in 2019 and before, it's like, hey, we have this big data sets, we have this years of historical data, so let's find the patterns, like very crisp statistical patterns in those data sets, and let's project them to the future, and this is how our forecasts will look like, right? That's how like a lot of the business kind of worked before 2020. And then of course for obvious reasons, like this way of continuing to apply machine learning doesn't work anymore, right? So we have to kind of think of creative ways of dealing with uncertainty, right? And here actually I think it's to some extent kind of a maybe renaissance, or basically like we have applied much more of kind of Bayesian methods, and we embraced uncertainty to a much kind of like as a first-class citizen in a way in modeling. Because it's not just kind of let's look at historical patterns and let's project them to the future, right? But kind of to sum up this part, it's about kind of maintaining models and kind of there is again one part in this in management which I briefly touched upon in the skills conversation, which is about kind of communicating with client, especially explaining black box models, right? Like clients often are not either are themselves not kind of satisfied with just saying, oh, this is some black box model which just gives good results. They want to understand why. So we'll go some Shapley, or like there are various approaches to kind of to unpack a black box model. Sometimes it's a regulator who basically mandates that it cannot be a black box, period, right? And there's of course a question of hidden biases of models and creating kind of models that are fair, and so responsible AI, I believe, is a big topic, right? And this is something which we all need to have in mind when we are building our models, and this is also a big part of what BCG is currently kind of focusing on, is to making sure that every model that we build has this kind of we have some frameworks for responsible AI, so that we are kind of fair in this respect now.
Mm-hmm. But have you ever encountered a project where you really had to, let's say, cool down the expectations of the client?
Oh yes, yes, of course. I mean, but that's natural, right? Of course, I don't want to give examples, right? And then it's not like we are experts in our fields, we are not experts in other fields. So it's, of course, we are ignorant in other fields, right? And that's so of course, sometimes we get some, questions which are like, or kind of, requests which are completely kind of impossible to fulfill, right? That's but with careful kind of like with, like polite explaining of what is possible, right? What is the, like more or less how, why, right? Also to the extent possible. Again, this is like the communication is an art in a way, right? To be able to explain, like kind of to give some justification in kind of in a more or less natural language why something is possible whereas something else is not, right? But yeah, for sure.
Okay, good. But maybe also Karol could provide us. I see Viorica also unmuted herself and wanted.
I just wanted to related to clients. It's just memories from my postdoc in Cambridge when we were trying to work with infrastructure owners to get it was a project where we're trying to reconstruct bridges and buildings and so on, large scale infrastructure buildings. And a problem that the clients had was that they always said, oh, we have data, we have lots of data. But then when you would get to them and look at the data that they had, it was in no way exploitable and in a machine learning setting. And also it was not enough. First of all, they often don't understand the scale at which a data set has to be usable in machine learning. So I think that is a challenge in applying machine learning. Another thing when you develop a machine learning project, from my point of view, is the debugging. That it's I find it way more difficult, the debugging, because maybe your model is not behaving as you'd expected, but you don't know if it's a bug in the code. You don't know if you didn't set up the problem correctly, if there's something that you could improve in the loss function or something. So I think the debugging, and also some frameworks don't make debugging easy. So that's kind of a challenge that I think, you have to have patience when debugging a machine learning setting.
Okay, and Karol, also an insight from you.
Yeah, so going back to your original question, what's the fundamental difference between managing projects that have AI components, like machine learning components, versus standard engineering projects? So for me, this question is mostly falls into two categories, right? So we may be developing a machine learning feature in some bigger system. Let's say we want a feature that gets you automatic responses to emails, which is part of Gmail, and the other bucket is pure AI research with the paper, with the goal of shipping paper to a top conference in mind, right? And in this first case of a feature, actually there are big similarities to managing engineering project, because maybe 80% of the work is actually creating a framework, connecting the data pipelines, do some correct pre-processing, scaling, inference, etc. And this last 20% is experimentation with various different models. At the same time, usually those models are kind of known. It's not you want to do research on some problem that you want to ship on the client. Usually you take some solution that was already battle tested and people know that it works good, people use ResNet or whatever, and you maybe tweak it, maybe you do some specific optimizations. And the other bucket, doing papers, is a completely different management style. So here, really everything is aimed at help the algorithm that you are developing. So we again switch to this academic mindset that okay, this code will be thrown away after the work, so we don't need to care that much about the quality. People need to have much better understanding of what you are doing, because there is the main difference between this and the standard engineering project, that there is no linear dependency between the time you put and the effect that you get. So it might be if someone very deeply understands what you are doing, they can suggest one tweak, okay, maybe I don't know, decrease the learning rate, or use this kind of normalization, or do something, and then the results skyrocket. So you need to spend much more time on making sure everyone else involved very deeply knows what you are working on. That's for me the main management differences in those kind of projects.
Mm-hmm. Okay, we got an interesting question from the audience. Maybe Łukasz could provide some insight here. So if we're talking about, let's say, the process of managing a machine learning project, the question is from Michał Kucharski. Do you think ML would become next engineering field with mainly automated tools? Do you believe that you can manage your projects, cut down on the amount of, let's say, data scientists involved with automated tools.
Mm-hmm. Yeah, and it's indeed a very interesting question, and I think a very interesting trend in the recent years, right? So on the one hand, of course, we will still have researchers, right? Like like people in the panel, right? You are researchers who who are on the cutting edge of things. So obviously, this is not a commodity, right? The things that you're building are are prototypes, right? So and of course, we'll continue to push the boundaries on the one hand. So the profession of data scientists will definitely will remain on the research front. I think also on the business front we will still need data scientists. But what I think is it might change in a couple of years. And for example, I've seen this based on our partnership with Data Robot. Like basically you can cut down the time, there is a lot of tasks which are very, I would say, manual or repetitive, or things which you can offload to a machine and say, okay, hey, so this is how I define the problem, this is my view on how the feature engineering should look like, and so on. Go and do this, right? And that's your silicon assistant who's doing these things for you. And I was really surprised at how much of that can be automated, and what's the when we recently, really we've seen basically some tasks go down from 8 weeks to 2 weeks when we embraced the auto ML solutions like Data Robot, because and also we were able to actually explore more, right? Because for example, we can now say, okay, so let's test over 100 different models with different architecture, and this all happens automatically. There's it will never cut corners, and will be very precise when it comes to evaluation, right? So there's always a holdout where it's somewhere, there's it's saving some data for various validation steps and so on. So this is I think definitely there is some room for making our lives easier, but but that's the same thing as with everything, right? With programming, now we have great IDEs, right? 20 years ago or 30, you would mostly work in text editor, right? Did IDEs make the programming job redundant? No, right? And of course, it's maybe not a perfect analogy, but I hope you see what I mean. These are tools which will help us to focus on what really matters, and and not on some fixing some syntax or preparing some features in a way that it can be automated away, right? So I think that's I would say that this is the main element here. Huh?
Mm-hmm. Okay, thank you very much. So now maybe one question for Eva on applicability of machine learning projects. So you work on projects regarding solutions for medicine. Do you ever get to see those projects actually implemented in real life, or are they some proof of concepts on which some companies can build up later?
No, I haven't seen my projects implemented in marketed or implemented by companies. So most of the time we work on basic research, and we develop models which, we don't intend to throw them out of the window after the project, as I think Karol mentioned. But we are actually very strongly working on reproducibility in research, which I think is a big problem in academia. So we do keep our models and try to somehow maintain them and make them, first of all, open access and available for everyone. But we don't make them to we don't push them to companies. We do have, in my lab, has a collaboration with pharmaceutical company, Merck. So there we have several common projects where at least they are using our models. So we're modeling, for example, how drugs act on cancer cell lines, and there, of course, we are modeling everything available about the drugs that we see in the public space, but then they are actually interested in 2 or 3 of their own drugs, and then they can look into our results from that perspective. So that, I think, is the only example that I can have from my lab.
Thank you very much. Maybe we could progress to next category, because we're quite getting quite short on time slowly. So maybe we can talk about a bit about the differences in industry research and academia research. So machine learning, as we all know, is quite of a weird field in the sense that you actually see a lot of the research comes from big companies, not only from the universities. So maybe a question for Viorica here. What do you think made it this way? As in, what enables companies to contribute so much to the research, and what makes them want to contribute so much?
So maybe to say that in machine learning, now the research is like very close to the applied. Like maybe in other fields, the research is very abstract, and you'd have to wait years for some results to become applicable in practice. Whereas I feel that in ML, we can see outcomes very, very quickly from the research. So I think companies are obviously very interested in developing in carrying out research, because it's then very quickly applicable, and you can create products out of that. And also, like, because machine learning with deep learning has become popular only like some years ago, it's still like a developing field. It's not mature enough, so companies have to do their own research to be able to develop products. And it's not like machine learning; it's already like a sold thing, and it's just a tool that you take it and you apply it to your data. Like every time when you apply it to a new data set, you have to investigate biases, you have to investigate like shifting distributions and so on. So like the people who apply machine learning tools, they have to understand them, and like they have to have the skills to understand them and do their own applied research, let's say, if we call it like that, to be able to apply the machine learning tools correctly and to get the best performance out of them. So I think the field in itself, because it's now growing, there's a lot of scope for doing research, which is why I think the companies are in a good position to do that. And of course, when we put in also like the need for lots of data and for lots of computational power, the companies have this more readily than universities. So I think this puts them also in a good position to do research in the field. But like what I'm hoping to see more and more in the future is a more collaboration between companies and universities, to not so that we don't have like a competition between the two. I think a competition between industry and academia doesn't serve anyone, because industry will always have more resources, and they will be able to, they have more funds, they will be able to attract the talent more than a university. But then if you take the talent out from academia, who will grow the next generation of experts? So I feel there needs to be more collaboration, and so that they collaborate in creating progress in the field.
Mm-hmm. Okay, thank you very much. But there are also there's also a lot of cooperation between private companies and academia. Do you think this cooperation benefits both of the environments, or just one, Viorica?
I do hope so. At least like the model that I'm trying to, or ideas that I'm trying to give to people in Romania is like DeepMind, for example, sponsors professorships in universities, so that like professors in university have good salaries and have access to resources. and they can grow like a research group in a university. So from that point of, I would hope that I think it's a win-win situation. Because like the companies can also get involved into the research projects that get developed, and like then the universities, they have the funding to do research, and of course the universities then the companies will then receive the talent that was created in the university. And I don't know, when we talk about IP, there could be also IP results and so on. But I see it as a win-win situation.
Mm-hmm. Okay. I'm happy to hear that. That's quite an optimistic outlook. So unfortunately, we have last 10 minutes of our panel. So now we should probably progress to a bit of a conclusion. And we have a bit of a concluding question. So AI is changing extremely fast, right? And now it's a different field than when you were starting your careers, probably. And I would like to do a short round of everyone answers of a question. If you were starting your career now, if now you're just fresh out of undergrad, you want to decide what you want to do in the future, what would be your direction? And maybe we could start with Karol.
Mm-hmm. By direction, you mean like academic direction, or like
in general? Like, would you head for a master's, for a PhD? Would you head straight to the industry? Would you make similar choices as you made in the past, or not?
Mm-hmm. Yeah, it's tricky question, because like the ML is like very different comparing to the time when I started. So for example, when I joined Google in like 2012, and I was like doing internships at Google previously, there was no such thing as like, you're in a research team like Brain, and you can do like any research you want, and maybe you can even make like PhD out of it sometimes, or like there were no dedicated programs like Viorica mentioned from DeepMind and other companies. So yeah, maybe I would consider some some kind of program like Google AI or like DeepMind fellowship or resident. I think it's called residency. So basically, you get to work with experienced researchers, and you have access to big computational resources, and together with their guidance, you can work on some like super cool problem. So, I mean, this feels much more interesting than like, starting maybe your tiny project on your own and having like 2 GPU cards to do the experiments. So that could be something that I might consider instead of doing PhD. But other than this, I mean, I think I would still invest in coding skills. I think I would still want to learn a lot about like ML basics, and I would still read papers. So like, I don't think there would be like any drastic changes.
Okay. And Eva, what about you? Would you follow the exact same path if you were starting it now?
No, I mean, if I would be starting now, I would go to my lab, right? No, I think, it really depends on the particular interests of the person, right? I really think if you actually want to do a machine learning in certain domains, at least, you really need to do a PhD first. So to somehow get the training into academia to understand the research problem, even, I mean, it's already super difficult to, of course, as we are all discussing, right? The area is developing and so on, and AI is so demanding because of how fast it goes, and but also the domain to which you apply. In particular, I really think the application to healthcare, application to molecular biology, to experimental data that is generated there. This also requires additional training. So the understanding of the field to which you apply is also very crucial in some domains at least. And I think that in particular, exactly what interests me, and I think it will also interest me when I would start now. So application to these particular problems would require doing a PhD, and this is what I would choose. But I agree that what has changed, if we are discussing what has changed when I started and now, is definitely the immense opportunities and really fantastic opportunities for individual development at companies and at the areas where these two collaborate. We also, for example, now will have a PhD student funded by a company, and I think that will broaden our collaboration, and that these possibilities are now open. They haven't been, and these are definitely something to consider.
Okay, thanks for pointing that out. Łukasz, what about you? You started in academia for a long time, and then you moved to consulting. What would you do if you started now?
Yeah, so I have no regrets, right? In a way, I think it's like so everything that I learned in the kind of 15 years in academia, kind of maybe a kind of a stronger profile in consulting, right? And it's like it were things which were maybe not that obvious, like like back when I was kind of doing them, that they would prove useful in the future, right? So like for example, I spent a couple of years in high performance computing, which then kind of like is for some kind of computational heavy problems. It turns out that this experience is useful, right? Like the general kind of mathematical modeling applied to very diverse set of problems. It like teaches you how to, how to kind of apply maths everywhere, right? So it's like, yeah, it is admittedly kind of like my career was like a slower career, right? Like if you want to get to a certain, I don't know, role or something like that, you probably can optimize for that. But I don't think that like life has to be about optimizing for getting a certain role before a certain age, right? It's about kind of having fun of what you do and kind of enjoying it kind of every year, right? So for me, I wouldn't change much. Maybe one thing which I think like, okay, a couple of things which are different now than where, like, let's say 20 years ago when I started was like, I think it's much easier to go abroad than it was. I mean, it was still possible. I'm not saying no, right? But it's even easier right now to go to other places, and it's an enriching experience. So I think I would encourage that. So that's one thing. And there's much more of kind of online resources that was kind of even 5-10 years ago. Like Karol mentioned Kaggle, and like so. Leverage that, right? Leverage the fact that we are living like truly in this spectacular age where there's like such an ease of getting information, right? It's of course it wasn't like that before. So this maybe would be some small kind of like tactical things which I would change. But overall, like my advice would be like do what you feel that is interesting for you, and don't worry about too much about about your like optimizing your career. Yeah, it will come.
Mm-hmm. Okay, thank you. And Viorica, what about you?
Yes, I couldn't agree more with Łukasz about the going abroad. So I know, like in general, Eastern Europe suffers from brain drain. Romania is that, and I know Poland also is that the case. But I don't see it as a bad thing. Like I see it as a good thing, exactly that we have the mobility, but then the countries have to prepare opportunities for people to want to go back. But I think like going abroad to study and maybe to even work for a few years, I think that's a really, really good experience, because you really get to be in a different environment and to accommodate to new conditions. And I think that really helps you get mature as a person and as a professional. So besides that, so I did a PhD, and I'm happy I did it because like doing a PhD you have ups and downs. Some things work well, can also be a very solitary experience at times. But I think this really pushes you to understand, to really focus on a topic and to give your best. It's like you can take the time during a PhD. You can take the time to think a problem through Whereas if you join directly a company, you might be pushed, oh, you have to get the results quicker because there's a project deadline and so on. So I think the PhD gives you time to investigate a problem properly, and you learn how to do research. You learn how to learn, or something like that. So I think it's good to do a PhD if you want to do like more fundamental research. But if you're inclined towards machine learning and want to see results faster, I think doing a master is great, and that can already open you so many doors to get very good positions in machine learning if you do a master on AI and machine learning related. So yeah, I think I would not. I guess I would not advise people to go directly from undergrad to companies to work. I think it's good to do internships during your undergrad to get the company exposure. But I think I would recommend to people to do a master. And yeah, the PhD then becomes optional, truly optional. But I think the master is good, so that you're in a good position to approach also like more research-oriented positions.
Mm-hmm. Okay, thank you for providing these tips and advice for people starting their careers now. I think this concludes our discussion panel, and so for now I have a couple of announcements before we finish. The first announcement is just after this panel on Hopin in the Sessions tab, you'll be able to meet our panelists in well, not in person, but in small chat rooms where you'll just be able to ask them a couple more questions. I saw that we didn't manage to address all of the questions from the audience, and a lot of them were very interesting. So please use this opportunity to talk to our panelists and squeeze out a bit of their experiences out of them. Yeah, so I invite you to do that. That will go on for 20 minutes after we finish the panel. And announcement number 2 is that after the last talk today, so at 8 p.m., there will be a small quiz where you will be able to win access to a Syndic AI platform. And I invite you all to take part in that quiz. Other than that, thank you very much for your attention, dear audience, and thank you very much for being with us, our panelists.